Hey, this is Mr. Beckstrom, and today I'm going to be taking a look at a fourth degree polynomial. And what we're going to do is we're going to use these three things to kind of try to figure out what these roots are. And remember, the roots are all the values of the variables that make this function equal to 0. They're all the values that are going to be the points on the curve that intersect the x-axis. And they'll also be the imaginary roots as well. So on a fourth degree polynomial, I should have 4 total roots. That includes all of my reals and my imaginaries. So I should be looking for 4 total roots because it's a fourth degree polynomial. So let's start with the Descartes rule of signs. That's basically going to tell me all of my possibilities for positive real roots, for negative real roots, and for imaginary roots. So for my positive real roots, what I'm going to look for is I'm going to look for the sign changes. So I start with positive, because this is a positive number. I go to negative, so this is that's 1 sign change, and I go from a negative to positive, so that's 2 sign changes. I go from a positive to a negative, that's 3 sign changes, and I go from a negative to a positive, that's 4 sign changes, and then I stop before I get to the equal sign. So that's 4 sign changes. So for my positive real roots, so I'm going to put a little p there, that's 4 sign changes starting from here all the way down to my constant. And then I'm going to, the Descartes rule of signs says that then I'm going to reduce that by 2 until I get to 0. So it could either be 4 positive real roots, 2 positive real roots, or 0 positive real roots. And then for my negative, what I'm going to do is I'm going to replace my x with a negative x. I'm going to replace my x with a negative x. So what that does is if I kind of look at my f of negative x, any exponent that's even, that's just going to stay the same because that negative value to an even exponent doesn't change. So that's going to stay x to the 4th. But an odd exponent will change signs because a negative number to a negative exponent does change signs. So that will become a plus. That will become a plus 6x cubed. X cubed. This will become, that'll stay a plus 9x squared. This will become a plus 24x because we're replacing x with a negative x, so that will become a plus 24x, and this will stay a plus 20. So when I replace x with a negative x, then everything becomes positive there. You see that? Now I look for the number of sign changes, and there are none. So for my negative real roots, I only have a possibility of a 0. So what that means is if I'm going to set up a little table here, if I set up a little table, and I'm going to do this right here, positive, negative, and imaginary. And there's an example of this on page 294 if you want to take a look at one of their examples. But if I have 4 positive real roots, that means I have no negative real roots and I have no imaginary roots, right? Because I have a total of 4. If I have 2 positive real roots, then I have no negative real roots because I have none there. And that means I have to have 2 imaginary roots because I have to have a total of 4. If I have no positive real roots, and I still have no negative real roots because I can't have any there, that means I have to have 4 imaginary roots because I always have to have a total of 4. So here is my 4 possibilities. So in no case can I have a negative real root. So if I look at a graph here, there's going to be no cases where my curve is going to cross the x-axis here on the left side of the y-axis. So it's not going to cross anywhere over there. I can't have any negative real roots there. All right, so that is the Descartes rule of signs. Now let's look at the theorem on the bounds. And what that tells us, and this is kind of a little bit weird, but what it says is that if I start with positive numbers and I use synthetic division, so if I start with like a 1 and a 2 and a 3 and a 4 and I keep going, that as soon as I use synthetic division and I get all positive numbers on the bottom row, that as soon as I get all positive numbers on the bottom, then whatever number I used to divide with, that I used for my divisor or my synthetic division, that's going to be the upper bound, that I can't go any higher than that. So let's just do one of those. So if I start with a 1 here in my synthetic division, and so this is 1, -6, 9, -24, and 20, right? And I'm just going to go until I get a negative down here. So you bring down the 1. 1 times 1 is 1. 1 plus -6 is -5. So right away I get a negative there. So I already know that that I can have a number that's greater than 1. That there can be some real number greater than 1 that crosses through the x-axis. So let's already go with 2. I have to get all positive number before I can stop here. So let's try 2. So same thing. Well, in fact, instead of doing a whole new one, let's just go ahead and use my eraser here. So I'm just going to erase that and erase this. And let's see if I do a 2. Then that's going to put a 2 times 1 is 2, but that's still going to get me so 3, 4, 5, 6. So 6 is the first number there that is going to get me a 0 there. So I'm going to go all the way up to 6 here. So if I get a 6, let's see how 6 works. 6 times 1 is 6, and then I can get a 0 because I can treat a 0 as a positive. And then that's 6 times 0 is 0. So that's 9. 9 times 6 is 54. Okay. 54 plus a -24 is 30. And 6 times 30 is 150. And 150 plus 20 is 170. All right, there we go. So what this tells me is that when I use 6 to divide, that my entire bottom row is now positive. And that's the first number, because if I used 5, I still would have gotten like a -1 there. If I used 4, I would have gotten a -2 there. So 6 is the first number, the first positive number that I got, where I had all positive numbers on the bottom there, or 0. So that means that my largest positive root can't be any higher than 6. That's my largest positive root. Now I can do the same thing, well, a similar thing with negative roots. Although I already know from the Descartes rule of signs that I can't have any negative roots, right? Because, why? Well, because I just found that out with the Descartes rule of signs. But if I wanted to find out what my smallest root was, I could start with -1, -2, -3, and then I'm looking for the first time that I have all alternating signs, going from positive to negative to positive to negative, or from negative to positive, negative to positive. In that case, I can treat 0 as negative or positive, just to make sure I have alternating signs. And then that would be my smallest one. But I don't even need to check them in this case because I can't have negative roots to begin with. So through the theorem on the bounds and the Descartes rule of signs, I know that all of my roots, all of my real roots, have to be between 0 and 6. Right? Somewhere between here. Actually, I know they can't be 0, because if I plugged a 0 in here, I get 20, and I know that's not a root. But so this is where all my roots are, somewhere in here. So now let's use the rational root theorem. let's use the rational root theorem. Now, if I was actually working out this problem, I mean, that's probably the first thing that I would do. But let's go ahead and do that. So the rational root theorem says that if I take, this is P over Q, so P over Q, where P is all the factors of the constant term. So all the factors of the constant term. So let me erase this here. So P is, what are all the factors of 20? So plus and minus 1, plus and minus 2, plus and minus 3, plus and minus, oh, not plus 1, getting ahead of myself. Sorry, plus and minus 4, all the numbers that go into 20, plus and minus 5, what else goes into 20? Plus and minus 10, and plus and minus 20, right? And all the factors of Q, which is just plus and minus 1. Q is the coefficient in front of the first term here, so that's just a 1. So only 1 and negative 1 goes into 1, and all of these numbers go into 20. So if I put all the factors of P over all the factors of Q, that those are all the possibilities for all of my rational real roots. However, I know that they all have to lie within here. So the only ones that I even need to really try are what? Because this is going to be like 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, and 20 over 1, and then all of those all over negative as well. But since I'm only looking between here and here, all I have to do is try 1, 2, 4, and 5. So if I have any rational roots, it's going to be one of those 4. So let's go ahead and use synthetic division on these 4 and see if we get any solutions here. All right, so let's try it on 1 here. All right, so we have 1, negative 6, 9, negative 24, and 20. Okay, 9, negative 24, and 20. So bring down the 1. 1 times 1 is 1, so that's a negative 5. Negative 5 times 1 is negative 5. Add those together, you're going to get a, you're going to get 4. Okay, and then 1 times 4 is 4. Add those together, you get a negative 20. Oh, look at that. And then it's negative 20. Add those together, and you get a 0. So 1 is in fact a root. 1 is in fact a root. So now, if we pull out the 1, we're going to get x minus 1 as a root, or as a factor, and then we're going to get x cubed minus 5x squared plus 4x minus 20. All right, because it's the remaining coefficients here. All right, and then we can keep doing this until we get it down to something that looks good. Now for the rest of these, I could keep trying these again. It still might be 1 again. I could keep using synthetic division on these, but this time I'm going to show you how to do the calculator because that's a good skill to have. I think I was in, let me go back to real. I was in, all right. So if I go up to, in fact, let me go ahead and I'm going to put this original equation in just because I can. All right, x to the 4th, so x fourth minus 6x cubed minus 6x cubed plus 9x squared plus 9x squared minus 24x x plus 20 plus 20. Alright, make sure that's right. Alright, and once I have that up there, I'm going to go to second window, which is my table set. Make sure that's on ask, that's on auto. And we'll go to second graph, which is my table. And let's go ahead and delete all those out. So we already know that 1 is a root, and when we put a 1 in here, we get a 0 there. That means 0 is equal to 0. Now let's try these other numbers, 2, 4, and 5. So is 2 1? It is not. Is 4 a root? It is not. Is 5 a root? It is a root. So I know that 1 and 5 is a root. So for this second one here, let's go ahead and use synthetic division on 5. So now I'm going to pull out a 5. And we're left with these coefficients here. So that's a 1, a negative 5, a 4, and a negative 20. All right. So I'll bring down the 1. 1 times 5 is 5. I'm going to get a 0. 0 times 5 is 0. I'm going to get a 4. 4 times 5 is 20. And sure enough, at the end, I get a 0. Which means that if I now pull out the x minus 1, which I already had, and the x minus 5, which is my new factor, I am just left with, instead of an x cubed, and now I go down to a 1x squared. There is no x term, and then I just have a plus 4, right? All right, so I've got 2 of my factors out, and I have 2 of my solutions right now. One of my solutions is 1. One of my solutions is 5. Remember, this thing is all equal to 0, equal to 0. Let me kind of give myself a little bit more space here. All right, so now the only thing I need to solve is this thing here. So let's set that equal to 0. So x squared plus 4 is equal to 0. So x squared is equal to negative 4. Oops, we're going to get our imaginary solutions now. So x is equal to, take the square root of both sides, is equal to plus or minus the square root of negative 4, which is, so x is equal to plus or minus, that would be 2i, right? Because that's 2 times the square root of negative 1, which is 2i. The square root of negative 1 is equal to I. So those are our other solutions, plus 2i and minus 2i. So that's our 4 solutions, 1, 5, 2i, and minus 2i. All right, and that is using all of those. So it's a lot of stuff. I know it is. I'm sure you're going to have some questions here. Please go to page 296, 297. Try to use some of these rules and theories, and we'll get through it. All right. I hope you all have a great rest of your weekend, and thank you. All right. Bye-bye.